Hello, my name is Brian Kenyon with Maya HTT, and in this video I'm going to demonstrate a method I use to create an accurate model representation of split loom that also updates an expression that can be used to put the length of the material needed on the drawing. The first step I'm going to do is I'm going to create a spline that will be used for my split loom model. Next, I'm going to go ahead and create a sketch on the front plane here, just to put a simple line that will update with the spline length. When I put my dimension, I'm going to create it with an expression, and I'm going to use the measure for the value, and I'm going to just click that spline and make the length associative. Next, I'm just going to rename this expression to the loom length and go ahead and finish my sketch. Once I have that, I can come in here and I'll show you some other expressions I created. So here is the loom length, and here are a few other expressions I created that will be used in this model. Next, I'm going to go ahead and just sweep a tube along that straight line, and I'm going to use the loom OD for the outer diameter. Next, I'm going to go ahead and just create a sketch for the ribs of the loom. I'm going to put an intersection curve here on the outside of that. Just turn this to reference, put a rectangle in here for my rib. And I'm just going to use the offset command to offset my loom ID line by the material thickness. I'll just change this to reference as well, since I won't use it for my revolve. Next, I'm going to set the loom ID. Just divide it by 2 because it's half of the diameter. And I'll set my loom rib width. And also from the bottom of this, I'm just going to place this one rib length away from the bottom. Now that I have that sketch completed, I can go ahead and revolve it. Make sure I subtract it. Now I can do a pattern feature to pattern that. So I'm going to select that feature, and I'm going to set this to pitch and span. My pitch is going to be the loom rib times 2. And my span distance is going to be the loom length. So whenever I update that spline length, my pattern feature will also update with it. So now that I have those loom ribs in there, I can go ahead and shell this to make it look like a split loom. And I'm just going to set that to the loom material thickness. Now that I have my split loom created, I can now use the global shaping command to make sure that my split loom always follows that spline path. So I'm just going to go ahead and reset this, and I'm going to go by curve. I'm going to make sure I select body faces, and my base curve is going to be that sketch curve, and my control curve will be the spline that I had placed. As you can see here, the loom now follows the spline. If I come in and modify the spline and add additional points, the loom will always follow the spline, and the length will always update to that spline length. Now I can actually come back in here and add my split to the loom to make it really look like a split loom. Just going to add a rectangle in here and set my split loom gap to 0.25. Put a midpoint constraint in here. And just make sure I'm going to set the distance of this to the loom OD, just to make sure if I ever grow my OD that the sketch goes with it as well. Now I can go ahead and extrude this and select through all for the distance. So now that I have my split in here, I'm going to go ahead and make the global shaping my last command. And you can kind of see that the split is now inside of that. I'm going to go ahead and delete these points, and I'm just going to make this a straight line to make it more manageable when I bring it into an assembly. Now that I have this a straight spline and it's much shorter, I'm ready to save it, and I can go ahead and add this to my harness as an assembly component. So first I'm just going to go ahead and go to the electrical routing application, and I'm going to go ahead and turn off all that bundle stock, just so it makes it easier to snap to my spline in my routing spline paths. I'm going to add that in by snap point, and once I have that split loom added in there, I'm going to go ahead and go to the modeling application. I'm going to go to modify that spline, and I'm just going to drag that spline point to where I want it to end. Just make sure I have entire assembly selected, and I'm going to just create points on that spline and just start matching it up to my routing spline path. Now this doesn't have to be perfect. This is mainly just to get a good representation of if you had a split loom in your assembly. Obviously you could just use the overstock method inside of routing, but that just sweeps a pretty simple 2D profile. This method gives you an accurate representation of a split loom. So I'll add a few more additional points in here and just tag them all along my routing spline path. Once I did that, you'll see here at the bottom of the screen that it's updating those faces in the global shaping. And now my split loom is along my routing spline path, and as you can see, the length got longer and everything updated. I'm just going to go ahead and save this split loom as a new model, and I'm just going to name it something specific for this harness assembly. And I just want to show in here, if I go to my expressions of this split loom model, I can also show that the length will update so we can know what length the split loom is, and we could use that length as an expression on a drawing table or wherever we wanted to use it. I'll just go back to the electrical routing application and turn on all my connections. And there you have it. That's the method I use to create an accurate representation of split loom in NX electrical routing. Once again, my name is Brian Kenyon with MyHTT, and thank you for watching.